As we mentioned briefly while talking about joins, where we're looking to retrieve information that combines data from multiple tables, there are different kinds of relationships between the data that are stored in different tables. And in fact, as we've discussed, the reason we call this topic relational databases is that the relations between data stored in different tables is fundamental to how they work and the power that they give us. So now let's talk a little bit about the kinds of relationship that can exist between data in different tables. Now, of course, data in two different tables might be entirely unrelated. We might have a table storing data about patients and another storing data about administrative offices in the hospital. Those tables have very little relationship to each other. But when data in two tables are related, there are three basic types of relationships between the data in two tables: one-to-one, one-to-many, and many-to-many. Understanding these different types of relationships and when they obtain is going to be fundamental to being able to operate properly with the data in multiple tables effectively and efficiently. The essential question here is how the data interconnects and interacts between the two different tables. So let's dive in. In a one-to-one relationship, each record in table A is associated with exactly one record in table B, and vice versa. So, as this diagram indicates schematically, each row in the first table has one row in the other table that it's associated with, and vice versa. Possibly we have a row that doesn't have an associated row, but you never could have more than one. So, for example, in a banking application, if any given customer can only have one account, we might have an accounts table and a customer table, and the accounts table points to the customer ID in the customer table, and every customer has a single account if they do have one, and every account has a single customer. If we want to select data, we can just join the data directly using an inner join, select from customer, join account, checking to make sure that the customer IDs are equal. Very straightforward, and you'll get exactly one record for each account and each customer in the output. Now, it's not always going to be the case where there's going to be a one-to-one relationship. And in fact, the non-one-to-one relationships are the much more interesting case. So in a one-to-many relationship, each record in table A might be associated with many records in table B, but not vice versa. Any record in table B has only one corresponding record in table A, but any record in table A might have more than one. As we can see in this schematic diagram, the first row has three rows that it's associated with, the second one has two, and so forth. So an example of a one-to-many relationship is if we're looking at customers and their banking transactions. Even if the customers only have one account, they have multiple transactions. So customer 1 has 3 transactions in the transaction table. Customer 2 has 2 transactions, and so forth. And they can have any number of transactions, but any transaction is related to only one customer, the customer who did that transaction. Knowing whether your relationship is one-to-one or one-to-many, or as we'll see shortly, many-to-many, affects how we represent the relation within the database tables and what kinds of operations we can perform on them in order to extract the data that we need as we need it. So again, here we can select using a join, and here we'll get potentially more than one output for every customer, because a customer with multiple transactions, it will say customer transaction 1, customer transaction 2 for that customer, and so forth in the output of the join, because it's a one-to-many relationship. The third type of relationship is a many-to-many relationship. This is the most general kind of relationship that we have. In this case, any row in table A might have multiple rows associated with it in table B, and any row in table B might have multiple rows associated with it in table A. In the case of a many-to-many relationship, we need to have a third auxiliary table to store the information about the relationship. This is because any given row can only store information about one possible associated item in another table. So if we have a one-to-one relationship, it's very simple. Either table can store that associated ID for the other table. If we have a one-to-many relationship, then whichever table has the many side of the one-to-many relationship can have a foreign key that points back to the other table, just as in the transactions table, we stored a customer ID which points back to the customer table. One customer, many transactions. However, if both sides can be associated with many rows from the other table, we need to use a third table, as in the following example. Suppose that our bank also makes loans, and loans can be joint between multiple customers. So we can have a single customer can have multiple loans, and a single loan can have multiple customers associated with it. The way that we represent that many-to-many relationship in database tables is we construct a third table, and we've seen this kind of table before without talking about it explicitly, which we can term a relationship table. And the purpose of this table is to store the relationship between customers and loans. Its rows store pairs of a customer ID and a loan ID. In this way, we can store any number of customers associated with any loan and any number of loans associated with any customer. We can have arbitrary pairs of customers and loans stored within the customer loan table here represented in the middle. That allows us to have this many-to-many relationship that we'd like to have. And now, when we want to join information about customers and loans, we now have to do a three-way join between these three tables in order to get the related data items. So if we want to select data about customers and their loans, we need to select from customer, joined with the customer loan table, joined with the loan table, ensuring that the customer IDs are identical and that the loan IDs are identical. In this way, then, we get the information about each customer together with each loan that the customer is a part of. So by understanding these relationships between tables, we can start to form a picture of the relationships between the different tables and the different entities that we're representing data about in our database. So we might have the customers table that stores information about customers. We might have a many-to-many relationship with the loans table that's represented by some other table in the middle that we didn't show on this picture. We also have a one-to-many relationship with the transactions table. We can then talk about, well, which transactions correspond to customers that have loans. We can look at joins across multiple tables, but by sketching out the relationships and understanding the types, whether they're many-to-many, one-to-many, or one-to-one, this gives us useful information about what kinds of operations, what kind of data can be retrieved, how we need to join that data together to find the data that we want, and how we can move forward. We're building up, step by step, an understanding of the structure of the database, which we'll get to in the next course when we talk about database design, and how the different operations of SQL allow us to find, retrieve, and manipulate this data.